Okay, so we're going to go ahead and go over this. Looking at the warm-up, what kind of function do you think we're going to be talking about today? Huh? Not quadratic. What kind of function do you think this would be? What do you see in the equation? A square root. So we're going to be talking about square root functions today and tomorrow and Thursday. Okay. I do square root functions with quadratics because they're, what do we think? Do we think they're related? Square root functions and quadratics. So let's talk about it because this goes into what we're doing today and I need y'all to understand this. My people at home, I think y'all are going to have to participate more because my people in class being kind of slow is not a nice word to use. What's a good word? I don't have one. Slow. All right, square root. Square root functions. How do you think these two are related? This is a quadratic. This is a square root function. How are they related? They're what? Not reciprocals. You're on the right track. Opposites. So what's the word for that? Do we know? You learned the word in math 1. It starts with an I. Inverse. Good, Sean. Extra credit. Square root functions and quadratics are inverses of each other. Taking a square root is just the opposite of squaring something, right? So these are going to be very similar to quadratics, just a lot of the ordered pairs are going to be reversed opposites, okay? So that's why we do these together. We'll talk about the domain and range in a second. Did you guys graph the function f of x equals square root of x in Desmos? Fantastic. So I'm going to switch to Desmos and graph mine, and we'll look at the graph together. So when you graph the square root of x in Desmos, this is what the graph of the function looks like. Is everybody okay with that? All right. So then we're going to skip question 1 for now. I'm going to do that at the end. Question 2 said, what observations can you make about the graph? There is no right or wrong answer. I just wanted some observations. So what did you guys say for observations? Oh, it goes on forever. Good, because it's a function. So it's going to continue going. Good. What else? It's only in quadrant 1. I like that. So I'm going to write quadrant 1. We're going to talk about that in a minute. What else do we notice? Okay, so what Chris is saying, the whole numbers, the x will equal the y if it's squared. Is that what you're saying? All right. Okay, okay. What else? He is right. I'll show you that in a minute. What other observations? That's a really good one, Chris. Extra credit. It's half. Good, Henry. Does everybody see that it's half of a parabola? My people at home, can somebody unmute so I can make sure I can still hear y'all?
Yes.
Oh, okay. There's Riley. Hey, Riley. Don't forget to participate so y'all get your extra credit. It's half of a parabola. What else? If you don't see that it's half of a parabola, let me do this for you right here. It's a sideways U. Yeah. What else? There's a big one y'all aren't getting. It starts at the origin and it goes where? Up or down? Up. Good. It starts at 0, 0 and increases forever. Does everybody see that? We're just looking at the red, not the purple. We'll talk about this in a second. Starts at 0, 0 and it goes up forever. It's not going down. It's going up. There's a reason it increases. There's a reason it goes up. And it relates to what Chris said and to what Carter said. Is everybody okay with those observations? Did anybody have a different one they wanted to share? Those are, I think, the main ones. Those were the 4 I had down. It increases. It's half of a parabola. If you take the x, the y is the square of it for each ordered pair. That's a whole number. And then it's in quadrant 1. If you did not have those, I would write them because I'm not redoing this in the notes. There's a reason we're doing this as a warm-up. I'm going to start taking y'all's warm-ups for grades. because I don't have a lot of you try your best on the warm-up. Those of you that do try, it'll help you out. All right, question 3, while you're writing, if you're catching up. What convenient points or whole number points are used to graph this function? So y'all, a lot of you seem to be struggling with this. I'm gonna keep it hot with you. I don't really know why. All you have to go do is find some whole number points in Desmos. So how do you find points in Desmos? What do we do? Click and basically try to find them. Oh, wow, there's one. What's the point? 1, 1, awesome. So I'm gonna put that in this table. 1, 1 works. What's another one y'all found? 4, 2, I agree. So everybody look, if you click right here, that is 4, 2. If you keep going, let me zoom out for y'all. 4, 2 was 1. What about right here? 9, 3. That boy said a big one. Okay, hang on. We said 4, 2, 9, 3. I saw Evan had 416 on his paper. I heard 525. Oh, I did that backwards. 25, 5. Thank you, L'Oreal. Good. 36 and 6. And then I want to go, it's going to keep going. Chris said 81 and 9, and we're going to stop there. That's great. What do you notice about the X's and Y's? How are they related? All of them are perfect squares. 1, 4, 9, 16. Those are all perfect squares. And y'all look, when you plug those X's in, I hope we're all paying attention. This is what we're doing today. When you plug these into the equation I gave you, the equation was square root of X. So if you do the square root of 1, you get 1. If you do the square root of 4, you get 2. If you do the square root of 9, you get 3. So what convenient points are used on this graph? Perfect squares, because those are the numbers we can take square roots of. Does that make sense? Should you ever, let's think about this one. I'm going to turn my camera back on. Should I ever be using X is 2 on one of these? What's the square root of 2? The square root of 2. It's irrational. Good vocab, Henry. Extra credit. Square root of 2 is irrational. Square root of 5 is irrational. Square root of 6, 7, all irrational. Should you ever be trying to put those in for the X? Not for a square root function. What kind of numbers are we going to want to use for square root functions? Perfect squares. Does that make sense? Okay, good. People at home, are y'all okay so far?
Yeah.
Okay. So then the last question, question 4, before we go into the notes and talk about the domain and range and everything, said, why do you think the graph is only in quadrant 1? So I'm going to tell y'all what some people in class wrote on their paper. They said, because it's always positive. Yes, but it says, why do you think that? So you can't just say because it's positive. We know that because it's in quadrant 1. So Chris has his hand up. Why do you think it's always positive? Okay. So what he's saying, if you have a parabola, I get what you're saying. I'm gonna word it for you. If you had a parabola, it would look like this, right? Yes? Okay, so let me ask y'all a question. With a parabola, let's say we wanted to say that X was -2. So then -2 squared would be 4. You can square a negative number, right? Okay, we're not talking about parabolas anymore. We're talking about a square root function. So this red function right here. What if I tried to have y'all plug in -2 as the X? Can you take the square root of a negative number? Why not? Good, it's imaginary, which means you can't see it, right? So can we have the square root of a negative? No, so this graph should always be on the right. The X's have to be positive. Now let's talk about the Y's. So let's look at this purple piece down here. Why do y'all think we don't have any negative Y's? I'm asking you a lot of tough questions today. Why do you think we can't have that purple piece down there? Well, if I take the square root of 16, that could be +4 or -4, right? So technically, it could be, the y's could be negative. Why do you think they're not on the graph? This goes all the way back to middle school. What's wrong with this red and purple graph? It's a what? That's okay. Well, we're not talking about quadratics anymore, so that don't matter either. What did you say, Jordan? It's sideways. Okay, you're on the right track. What about it being sideways? It can't be sideways. Why? Somebody at home help them out. Yikes. My little freshman can tell me this. Uh-oh. All right. Nobody at home wants extra credit today? What's wrong with that? I mean, yeah, it does have an axis of symmetry. It's just sideways now because the graph's sideways. Yes. Say it again, louder for the people in the back and the people at home. You cannot have a function. A graph is not a function if it touches the same x value in two different places. This isn't a function. If you have the purple piece down there, it's not a function. So how did they decide which piece to keep, the red or the purple? Why do you think they chose to keep the red? This goes to what you were saying. Well, because it's positive. So in the real world, are we going to have a lot of stuff that's underground? No. So they chose to keep the red piece, just the positive piece, because that's the kind of functions you'll see in the real world. So when you do a square root function, it is only in quadrant 1. I'm quizzing you. Tell me why. Why is it only in quadrant 1? It wouldn't be a function if it was in both. We can take the square root of a negative, so they chose to keep the positive piece. Very good. Does that make sense? When you see like part of a parabola, but it's sideways, and you see half of a parabola and it's sideways, that is a square root function. On your test, there are graphs of square root functions, and it says write the equation. If you write a quadratic equation, are you going to get credit? Y'all are looking at me like, why would you write a quadratic if it's only half a parabola? I don't know. Half my kids do it every year because they don't pay attention. They'd be writing x squared, and I'm like, that's only half of a parabola. Why? Okay? So you see half of a sideways parabola, that is a square root function. So that's what we're going to be talking about today. So I'm going to pause the recording. All right, topic 27, square root functions and transformations. So I'm going to go ahead and flip. All right, so what are some properties of square root functions that we wrote down in the warm-up? Remember, I'm talking about the function f of x equals square root of x. Oh, Lord. Y'all, what were some things we wrote down? Yeah, question 2, question 3, or question 4. Tell me some things.
Only in Q1.
Only in quadrant 1. Thank you, Beatty. So it's always increasing and positive, which means it's in quadrant 1. Extra credit. Good job. What else did we write in the warm-up? Good. The x will equal y squared, or that means the square root of x will equal y, right? You can think of it either way. It's what? I can't hear you. Half of a parabola. Good. The mask muffles you, girl, and you're just naturally soft-spoken. It's half of a parabola. Very good. Half of a parabola. And remember, that's because they are what? Inverses. Good job, L'Oreal. Extra credit. Very good. So it's going to look like half of a sideways parabola. And there's one other thing. What kind of numbers would we have in a table for a square root function? Okay, yes, whole numbers, but what kind of whole numbers? Perfect squares. Good. So y'all, I want you to write down this table. So we're going to call this the parent table. And we'll just do 3 points if that's okay with y'all. Haley, do you need me to write bigger or neater? Inverses. So your parent table for a square root function. What's the square root of 0? 0. What's the square root of 1? 1. Very good, Carter. Now, can we use 2 as the x? Nope, not a perfect square. Can we use 3? Nope, not a perfect square. So what would come next? Good. What's the square root of 4? Good. If you know those 3 points, you are golden for the first unit in honors pre-cal. First unit in honors pre-cal is talking about graphing quadratics, square root functions, and then cubic functions, which you'll learn about in Math 3 by transformations. So these are our properties of square root functions that we talked about in the warm-up. So while you're finishing writing, does anybody have questions on the properties? All right, so then the second thing we're going to talk about is transformations. So we already wrote down under properties, how are square root functions and quadratic functions related? They're inverses. Very good. So let's talk about it, and you do not have to write this. I just want you to actually see it so you understand. If we had a quadratic function, again, I do not want you writing this. When we did quadratic functions, we would use 0, 1, 2 to graph it still. What's 0 squared? 0. What is 1 squared? 1. What is 2 squared? 4. So do you notice how all the ordered pairs are just flipped? Okay, that's what makes them inverses, is that their ordered pairs are just opposites of each other. That's what an inverse is. You'll learn more about that in Math 3. Usually we do more with that, but since y'all are virtual, I'm not going to. So they are inverses. Since they are inverse functions, thank you. You mess with my ADHD. Since they're inverse functions, most of their properties are going to be the same. Like things we could do with quadratics, we'll also be able to do with square root functions. So transformations are going to be done the same way. If it's a horizontal shift, I'm just reviewing with y'all before we write it down. If it's a horizontal shift, that means it affects the x's. Good. So the number will be inside with the x. If it's a vertical shift, it affects the y's. So it's going to be on the outside. If it's a stretch or compression, where's it going to be? Where do you think? Uh-oh. Transformations. Whenever we had a stretch or compression with quadratics, where was that number found? A. Very good, L'Oreal. Extra credit. It's the A value. What y'all talking about? Negative, or I heard some other weird stuff. What's the negative do? Flips it. Guess what? That's what it does here too. So if you do see a square root in the negatives, it's because we flipped it. Okay? Transformations are done the same way. So I feel like we need to rewrite these because some of y'all were struggle busing just then. All right. Y equals A square root of x minus h plus k. That should look familiar. It looks just like the quadratic one, except it has a square root. So again, for my people watching this later at home, this looks the exact same as a quadratic function in vertex form. If it was in vertex form in a quadratic, there would just be parentheses here instead, and it would be squared. So we're going to do transformations the same way. So I'm going to let y'all tell me what you told me earlier. What does the A value tell us? If it was stretched or compressed. If there's no number out front, it's an understood what? 1, which means we didn't stretch or compress it at all, right? So when do we have a stretch? And let's call it a vertical stretch because when you get to pre-cal, you'll do horizontal ones as well. Okay, when it's bigger than 1, it'll be stretched. When is it compressed? Ooh, yes. Okay, I heard when it's in between 0 and 1, which means it's what kind of number? A fraction, right? Fraction or decimal? Sean, you got this, bud? So you're going to look at your A value, and that'll tell you if we stretched or compressed it. What does the H value inside do? Y'all don't make me sad on a Tuesday. What's the H do? Yeah, what with the X's? The word starts with the H. Horizontal shift. There you go. So this is your horizontal shift. The same rules from quadratics apply. It's always going to do the what? Do y'all remember? Opposite of what it looks like. Your ex is your ex for a reason. Ex-girlfriend, ex-boyfriend, whoever. They did the opposite of what you wanted them to do. Okay? So your horizontal shifts always do the opposite of what they look like. So if it says -3, that really means it moves right 3. Good. If it says +4, it's really going to move left 4. Very good. This really shouldn't be new. We should be okay with this. And then what about the K? What is the K? The vertical shift. Good. Vertical shift. And does the vertical shift do opposite? No, it'll do whatever it says. Very good, y'all. I'm going to give y'all a second to get that copied down. So when we do these examples with the transformations, I'm also going to show you at the same time how we can use Desmos to graph it. And we're going to go ahead and talk about how you would find the domain and range, because I feel like we should be able to handle that, okay? So let's go ahead and jump into examples. All right, so for example 1, I gave you a square root function, and I'm asking for the transformations, the domain, and the range. These are the 3 things you'll be asked for on today's assignment. Okay? All right. Should you need to go graph this to be able to tell me the transformations? No, you should be able to look at it, list out those transformations. Now for domain and range, we're going to want to look at what? A graph. And I'm going to let you use Desmos to graph it. I'll show you tomorrow how to graph by hand, okay? But I don't think many of you are going to choose to do that. So transformations, how did we shift this square root function? What did we do?
Down 1.
Good, BD. Vertical shift down 1 because there's a -1 on the outside. What else did we do?
Left 3.
Left 3. Does everybody agree this square root function went down 1, left 3? Okay, so without graphing it, some of you already graphed it. Wait for me. I don't want you graphing it yet. Without graphing it, can y'all tell me what point this square root function is going to start at? -3. -1. Well, you said that. Everybody else was looking at me like I was talking Spanish. ¿Tú hablas español? No, I was not talking in Spanish. If you move it left 3, down 1, instead of starting at 0, 0, it's going to go to -3, -1. So that's where our vertex point is going to be. Does that make sense? We should remember that from quadratics. So now to find the domain and range, we're going to go graph it in Desmos. So I'm going to pause and I'm going to go to Desmos. All right, so when I graph this function, x plus 3 minus 1, I'm going to zoom in so y'all can see better. Does everybody agree? People at home, can y'all see my screen? Right.
Yeah, I can see.
Oh, thank you, Vidi. You see the graph, right?
Yeah.
Awesome. So y'all look at this graph. When you graph this, what's the vertex? -3, -1, because we moved it left 3, down 1. Okay, it's not at 0, 0 anymore because we shifted it. So when we're doing domain and range, because that's the other thing I asked you for, can you guys tell me what domain of a function means? What am I asking for if I ask you for the domain? I'm asking, good Carter, I'm asking for all of the x values that can be found on this graph. So what x value does this start at? Because it's not negative infinity to infinity anymore. Very good, boys. Okay, hang on. They said it starts at -3. I agree with them. Does everybody see it starts right here at -3? And then it goes which way, left or right? It goes to the right forever. It keeps going to the right. If you zoomed out, it keeps going and going and going. So it goes to what? Positive infinity. Good job, y'all. So when I ask you for the domain, when I asked you for that in the warm-up, I was really hoping we could have written 0 to infinity. Some of you did. Saw about 3 or 4 of you. But it's always just the smallest x to the biggest x. Any questions on the domain? Yes. Okay, so let's talk about it. That was a great question. He said, so the domain now is going to have brackets. Y'all look at this. When I click on this graph and I drag down, there is a point sitting on -3, -1. So we are including -3. That's where it'll start. And it'll have every number from -3 all the way to the right. So you do need a bracket. Any other questions on domain? Oh, that's a great question. All right, let's talk about the range. Range is the what value? Spread of what? Y values. Connor, you paying attention? Spread of the Y values. So the smallest Y up, because this is going up, right? Up to the biggest Y. So look at the smallest Y. Do y'all agree it's -1? Okay, there's a point sitting there. We already said that's the vertex. So do we include the -1? Yeah, so you also need a bracket on -1 for their range. So look, my range is going to start at -1, and then it goes up from that point till it hits what? Infinity, positive infinity, because it's going up. Are we okay with example 1? Y'all are good? People at home, any questions on example 1? Parker, Soraya, Riley, Veedy, Macy, Jeremy, Tyler? All right, so example 2, y equals -square-root of x plus 5. We're going to find the transformations, the domain, and the range again. So before you graph it, I need you to get in the habit of this because you should be able to just look at it and tell me the transformations. What are the transformations undergone by this square root function? Left 5, very good. It is shifted left 5. So it's not going to start at 0, 0 anymore. Where's it going to start? -5, 0. Very good, Sean, because we moved it left 5. Good, good, Henry. So it goes left 5. What other transformation do y'all see? A vertical reflection. So let's talk about it. If we flip it vertically, I'm just going to graph this for y'all really quick. So I want everybody to watch. Draw me a little coordinate plane. It's supposed to start at 0, 0, right? But we shifted it left 5. So does everybody agree? I need to see eyeballs. Does everybody agree it's going to be over here 1, 2, 3, 4, 5 at -5, 0, what Sean just said? That's going to be the vertex. Now let's talk about it. Normally, it would be positive, so it would go up and to the right. If we flip it vertically, it's no longer going up. Where is it going to go? Down. So I need you to remember it's a vertical reflection. That doesn't mean it goes to the left. It's still going to go to the right because we're not flipping it horizontally. But instead of up, it's going to go down. Does everybody see that? Yes? So when we graph it in Desmos in a second, nobody's going to be surprised that it's going down, right? Because we flipped it vertically. Connor, are you okay, babe? All right. So vertical reflection, I agree with. Left 5, I agree with. So now to find the domain and range, what should we go do? Graph it in Desmos. Very good. So let's go to Desmos. And we're going to type in negative square root of x plus 5. I'm going to put the negative out front. Ooh, and it sure did flip it. So I want y'all to look at this. Negative square root of x plus 5. Everybody okay? All right, let's take a look. Y'all ready? People at home?
Yeah.
Where's the vertex? Where's the initial point? What's this point up here that it starts at? Good, negative 5, 0. So when we're finding domain and range, this is the point we're going to need to use, that negative 5, 0. Okay? So the domain, remind me again, I want to make sure we're all good with this. We should be good with domain and range when we hit Math 3. I get upset when there's pre-cal kids that can't tell me domain and range. It happens every year. When we find the domain, what are we looking at? X values, the smallest x to the highest x or biggest x. So what's the smallest x? What's the x on the left side? Negative 5, and that point is sitting on negative 5, 0, so we're going to include it. And then for the x's, do y'all agree it does go to the right? So what's it going to? Positive infinity, because it goes on to the right forever. Good job, Chris. Y'all okay with that? All right. What about the range? What are we looking at for range? The y values. Good. Okay. They're all saying 0. Now, hang on before y'all write that it starts at 0. This graph is going down. When you do range, you're supposed to do the smallest y to the biggest y. The smallest y would be at the bottom. The biggest y is going to be whichever one's highest or at the top. So if this keeps going down forever, what's the smallest y? Yes, negative infinity. Very good, y'all. What's the biggest y that it reaches? 0, and you need a bracket. It's going to the right, meaning the x's go to the right. The y's aren't left and right, though. The y's are up and down. So you got to go bottom to top when you do the y's. That's a good question. You're getting all that extra credit today. Any other questions on transformations, domain, and range? I got one more thing to show you if y'all are good with this. All right, so this right here, this is going to be example 3. So what we're going to do in example 3, we're going to list the transformations, and then we're going to write the equation. So I'm going to put that down here. So I'm going to pause while y'all draw this graph in your notebook. You are going to want to draw it, I promise you. Okay, I'm going to pause, sketch the graph. If you need me to give you ordered pairs, I can. To find the transformations from a graph, we did this when we dealt with quadratics. Good Lord, let me get to the page. All right, everybody can hear me, right? And see? Pay attention. You got 2 of these on your homework tonight. When you're given a graph, you should be able to look and find the transformations. So let's talk about it. Where should a square root function normally start? 0, 0. This one is not at 0, 0, which means we shifted it, right? So where did we shift this one? Right 3, very good. Let me get on my writing tool. Right 3. What else did we do to it? Down 2. Is anybody confused about how it's right 3, down 2? Look at the vertexes right here. And then this is where some of y'all struggle with quadratics. So this is why I'm taking so much time on this and making sure we're good again. What else do we have to check for? Stretches or compressions. Let me ask you a question. Do we need to check for a reflection? Why not? Okay, they said it's going up. It's going up and to the right. Everybody went like this. So there is no reflection because it's going up and to the right. You do have to check for a stretch or compression. So here we go. Review from quadratics. What is the A value supposed to be? 1. Let's see who remembers. That means I go over to my vertex and go over 1 and see how many it goes up or down, right? This one's going to go up because it's not reflected. Do you guys remember when we did quadratics, having to go over 1 and see how many it went up or down to find the A? Same thing we're doing here. So everybody look, how many does it go up to get to the next part, to the next point? Up how many? Okay, 2 is bigger than 1. If it goes up 2, what did we do to this square root function? There y'all go, stretch by 2. And make sure you say vertical stretch. Vertical stretch by 2. So I'm going to pause for a second and see what questions there are because that's where y'all struggled with quadratics. Some of you, it did not click why you went over 1 and then however many up or down. The A value should always go over 1, up 1. Do I still have it? No, I do not. I got it right here. In your table, I'm going to draw this so somebody can see. In your square root table we just wrote earlier, we said it should start at 0, 0, and then it should go over to 1 and up to 1. There's the 1, 1. That's why you go over 1, up 1 normally. But if we stretch it, when we go over 1, it's not going to go just up 1. It's going to go more than that. Does that make sense? People at home, are y'all okay with how this is stretched by 2? Go over 1, see how many it goes up or down by. Going once, going twice. Sold. All right, so to write the equation, if you guys would just list out the transformations, then it would be really easy to write the equation. What goes out front? A 2 because it was stretched by 2. What goes underneath the square root? X, ooh, good. I heard X minus 3 because it goes right 3. And then minus, not 1, 2. There you go. Then minus 2 because it goes down 2. Very easy to write the equation if you will list out the transformations. And then just plug them in. So I'm going to pause here for questions. If you don't have any questions, you're going to go do your worksheet assignment. It tells you what numbers to do because you don't need to do all of them. If you need to see another graph example, also stay on because I can give you another one.